Okay. Yep. Now I'm start recording already. Recording now. Okay. Start recording already. Okay. Let me. Okay. All right. So today we will start learn about radioactivity. Okay. Radioactive. Uh, previous lesson, you did learn about this graph. Okay. You learn about binding energy per nucleon. Okay. It is actually about stability. Yeah. It is a measure of nuclear stability. Yeah. We know that the higher the binding energy per nucleon, the more the stable the nucleus. So you have a graph here. It shows that you see the highest value graph here has the highest stability because it has the highest binding energy per nucleon. Yeah, the highest graph here has the highest binding energy per nucleon. It has also the highest stability. So, but heavier nuclei like uranium, it has lower binding energy per nucleon, meaning it is less stable. Less stable. So, nucleus which are less stable, they are called radioactive. Radioactive. They tend to decay or tend to break off to become a smaller nuclei. That's why today we learn about radioactivity. Okay. So what is radioactivity? Is something this we call it the radioactivity or radiative decay is the disintegration. Recording already, right? Recording. It's the wait, I want to check whether my sound, okay, my sound is recorded also. All right. Okay. So radioactivity or radioactive decay is the disintegration, or we call it break off. Break off of unstable nucleus to become more stable daughter nuclei. So unstable nucleus is normally is big nucleus. Very large nucleus like uranium, unstable, low binding energy per nucleon, very unstable. So he tend to break off to become a smaller daughter nuclei. We call it daughter nuclei. Daughter nuclei means smaller nuclei lah, smaller nucleus. With less proton and neutron at the nucleus. So they tend to break off. The big nucleus tend to break off to become a smaller nucleus, more stable one, with the emission of alpha, beta, and gamma ray. So during the disintegration or break off of the unstable nucleus, they will also emit. They will also got this what we call radioactive ray coming out from the disintegration. We call it alpha, beta, and gamma ray, and these rays are dangerous. These radioactive ray are dangerous. Understand? Radioactive decay is a spontaneous and random process. What is it mean by spontaneous and random? Spontaneous means the reaction is unplanned, cannot be predicted, and independent of physical conditions such as pressure, temperature, and chemical changes. That means spontaneous means what? You cannot unplanned. That means you cannot plan at what time it will disintegrate. It will disintegrate by itself. It's spontaneous. Cannot be predicted. That means we cannot know when. When is it When is it? I think I have to make this smaller. Right. So unplanned. So that means cannot know when. When is it? Disintegrate? We don't know. We don't know when is it disintegrate. It will just disintegrate by itself. That's called spontaneous. Independent of all physical conditions, like pressure, temperature, and chemical changes. So we can say they are independent. Independent of all this pressure, temperature, and chemical. You put acid or you put alkali. It won't change. It won't quicken the reaction. It won't accelerate the reaction. Even you put a high pressure or you boil it under hot water, the reaction the reaction rate still constant. That's what I mean. The reaction rate, the rate of reaction. You study about chemistry kan? You study about chemistry, you learn about rate of reaction, isn't it? Kecepatan tindak balas. So the rate of reaction is independent of pressure and temperature. That means you put it under a high temperature in the microwave or oven, or you put it high pressure cooker. The reaction rate is still constant, independent. Understand? So this reaction cannot be controlled, or in other words, this spontaneous reaction cannot be controlled. We cannot manipulate. Cannot be manipulated. Maksudnya manusia tak boleh buat apa-apa lah, tak boleh buat apa-apa. Cannot be manipulated. Yeah, independent of all these physical conditions. Alright, it just happened by itself. Spontaneous. Now random means what? Probability of nucleus decaying at a given instant is the same for all the nuclei in the sample. The probability is the same for all the nucleus in the sample. That's random. Random means what? We also cannot predict which particle. Just now is cannot predict when. This one is cannot predict what? Which. Cannot predict which nucleus will decay. Cannot predict which nucleus will decay. So that means I have a sample. Let's say I have a sample. I need to change the dinner. Okay, I have a sample of uranium. How many nuclei are there? How many uranium-238? 239 blah. Okay, this is a radioactive unstable nucleus. Radioactive unstable nuclei means plural lah. Yeah? Nuclei means a lot of nucleus. Yeah, in plural form we call it nuclei. So I have a sample here. How many nuclei are there? Let's count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So 7, 3, 21. 21. I have 21 of this. Yeah, I have 21 of these radioactive unstable nuclei. So all these are radioactive. Anytime they will decay, anytime they will decay. That means anytime it will decay. Yeah, but I cannot predict which particle will decay. I cannot predict. It's random. The probability is the same for all the nuclei. Yeah, the probability is the same for all. So it can be which decay? Maybe is this one decay? Or can be this one decay? Cannot predict which one it will decay. Maybe it can be this one decay. So the probability is the same for all. Cannot predict which particle will decay. Understand? Cannot predict which. Cannot predict when. Cannot predict which. So spontaneous means cannot predict when. Random means cannot predict which. Yeah, it's a probability is the same. Understand, class? Understand? So it can be random. Yeah, any particle will decay. All right. So now, three kinds of rays. These are dangerous. These are all dangerous radioactive rays. Okay, so these are what we call the alpha particle, beta particle, and gamma rays. Pay attention. Alpha is particle, beta is particle, but gamma is called rays. Gamma is called rays. Why? Why alpha and beta are called particles and gamma is called rays? Remember we learned about electromagnetic wave. Yeah, we learn about so I have to change all the phone here. Yeah, we learn about magnetic wave, magnetic wave before, right? EM wave. You learn about the done. Remember this? We have here, we have ray. Sorry, I have to change. Okay, so we learn about radio wave. You learn about micro, and then infrared, visible light, and then we have UV, ultraviolet, and then you learn about what else? Ultraviolet then is X-ray, and then gamma ray. Not grammar, gamma ray. So this is the one, yeah, gamma ray. So only the gamma is actually a ray, yeah, a ray. Like it's a wave. The rest, alpha and beta, they are called particle. Why they are called particle and they are not ray? Because they are just particle. Only gamma is a wave, yeah. Only gamma is a wave, gelombang. The alpha and beta, they are particles. Because alpha is actually, change the phone. Yeah, I changed already. Okay, the alpha is actually helium particle, helium-24, and beta actually is electron. We actually have negative electron. We also have positron. We call it, yeah, positron. Later we will learn about this. Okay. So alpha and beta, they are called particles because alpha is helium, beta is electron, and gamma is electromagnetic wave. Yeah, it's one of the spectrum of the electromagnetic wave, the very high frequency one, the gamma ray. Understand? Okay, so now let's look at each decay. Class, are you with me, class? Leave a thumbs up if you still with me. Okay, you understand what I'm talking about? Okay, so now alpha decay. So alpha decay is alpha is helium, yeah, helium. So helium-24, yeah. That means this helium, it has 2 proton and 2 neutron, yeah. The nucleus has 2 proton and 2 neutron. So if alpha decay, we need to know how to write the equation. Like you see, this one, let's say X612. So if decay emit one alpha particle, that means 6 minus 2 become 4, and then 12 minus 4 become 8. You must know how to write, yeah, and then release some energy. Okay. And beta decay, beta, it has 2 kind of beta particle. One is called beta negative. Beta negative is actually electron, or we call it negatron. Negatron because negative lah. Negatron because it is negative. So that's why negatron. Yeah. So it's not megatron. It's negatron. Okay, so electron is E0 negative 1. Then we have beta positive. We call it positron. Positron because it is positively charged. Just now it's negatron because negative charge. Negative charge. Positron because it's positively charged. Yeah, we call it positron. This one is not proton, class. This one is not proton. It's not proton. It's just an electron with positive charge. It's still electron, but positively charged. That's why this is all particle physics. Yeah, particle physics is not like what you learned before. Yeah, something you have always have very new things. Yeah, it's quite a difficult subject. Yeah. You will encounter a lot of weird things here. Yeah. So it is a electron with positive charge. That means what does it mean by electron with positive charge? That means it still have mass of electron. It still have mass of electron. It's not the mass of proton. It's not mass of proton. It still have mass of electron, just this electron has a positive charge. Have a positive charge like the proton. Understand? It still is an electron with mass of electron, but with positive charge. Before this, we always only use this negatron or electron. We don't use positron, right? But this topic, we will start to learn about positron. What is actually positron? Positron actually, okay, in short, I can say positron is actually, we call it antiparticle. Yeah, positron is antiparticle. Antiparticle of electron. Antiparticle of electron. Okay, understand? Antiparticle of electron. So what is actually antiparticle? Okay, all right. There is a joke lah. Yeah? Antiparticle is like, as a opposite version of positron is a opposite version of electron. If you watch the Superman versus Lois, right? You will learn about this bad Superman. Right? You have a good Superman. So the antiparticle of the Superman is a bad Superman. Yeah, evil Superman. So yeah, you encounter this antiparticle of maybe let's say you can see me on the Earth I'm black hair, but in other planet the reverse version of me is white hair. Something like that. Yeah, antiparticle. Yeah, opposite version of a subject. Yeah? Opposite version of a subject. Yeah. So positron is something like that. Yeah, opposite version of electron. Okay. Okay. So I won't talk so much about this. Yeah. They say the scientists say probably for every subjects on the Earth there is a reverse version, opposite version of what we have right now. So ada Mr. Peck. Kalau di planet lain mungkin ada Mr. Peck yang opposite, ya, sifatnya opposite, langsung opposite macam tu. Okay, I don't know how true is that, but that is a theory. Yeah, that's a theory. Okay, we have antiparticle of everything. Yeah, we have on Earth. Okay, now let's not elaborate too much on that. Okay, so let's talk about this. We have beta negative decay and beta positive decay. So beta negative decay, as just now we learned, beta negative is what? Electron, yeah, or negatron with negative charge, yeah, negative charge. And then beta positive decay is the what we call the positron with electron with positive charge. Yeah, electron with positive charge. Electron is with negative charge. Positron is electron with positive charge. Yeah. So we must know how to write the equations. If we want, beta negative and beta positive decay, we must know how to write the equation. Okay. So what is beta negative decay? How to write the equation? Okay. So beta negative decay is unstable nucleus. The unstable nucleus has too many neutrons compared to protons. That's the difference. It has too many neutrons. Whereas for beta positive decay, it is because you have too many protons compared to neutrons. Okay. Beta negative is because you have too many neutrons compared to protons. Beta positive decay is because you have too many protons compared to neutrons. Okay, maybe you don't understand this. Yeah, don't be afraid. Let's look step by step. Okay, so here is just a fact first. Yeah, beta negative decay is because it has too many neutrons compared to protons. So one of the neutron has to convert to proton to balance out. Whereas the beta positive decay is because it has too many protons compared to neutrons. So it have one of the proton have to convert to neutron to balance out. Okay, what does it mean by this? So look carefully. Yeah, I give one example here. So let's say you see here. Now it's beta negative decay, or we call electron decay. Let's look at here. So here we have a carbon 14. Carbon 14. Alright. Carbon 14. Look carefully. Carbon 14. So this is a carbon 614. So how many? I want to ask you, how many proton? How many proton are there? How many proton? Tell me, class. Open your mind and tell me. How many proton? How many proton is this carbon 614? How many carbon? How many proton? Proton. How many?
6.
6 proton. Good. Now, how many neutron are there? How many neutron? That means we use 14 minus 6. What we get? Tell me. How many neutron? 8 neutron. Right. So we can see it has too many neutron compared to proton. Actually, this proton and neutron, they should have almost the same number. Yeah, they should have almost the same number, but you can see neutron are more than proton, kan? Neutron are more than proton. That means it has too many neutron compared to proton. Okay, so now, so it will decay. So this carbon 14, it will decay because this carbon 14 is considered unstable. Yes, too many neutron compared to proton. Okay, so when it beta decay, so what happen is it emit one electron. Dia keluarkan satu elektron. Elektron ini macam mana nak tulis elektron ni? Elektron ini macam mana nak tulis? Sorry, here this one. How to write the electron? Electron memang elektron saja, dia tak ada nukleus, kan? So dia kosong lah, dia tak ada proton, tak ada neutron. So mass numbernya 0. Okay, tapi dia negative 1. Kenapa negative 1? Sebab dia apa? Negative charge. Negative charge. Dia negative 1 lah, negative 1 charge. So bila dia keluar ke negative 1, so what happen is tadi ini 6 jadi 7. So nak balance left and right, kan? Balance left and right. So ini macam 7 tolak 1 dapat 6. Understand, class? 7 minus 1 you get 6. So this one become 6 become 7. It's like 7 minus 1 you get 6. This one minus 1 because it is electron. Understand, class? Understand? Okay, are you still with me, class? Alright, yang lain hanya Sufika seorang kah? Yang lain kamu I don't know, you open Google Meet kah, sedang tengok kah, apakah? Atau you buat kerja lain kah, mana saya tahu, kan? Saya bukan di sisi ada kamera tengok you buat apa. So I need your response to know that you still with me, ya. Okay, so ini 7 minus 1, you get 6, isn't it? So that means when it emit electron, negative 1, so ini 6 perlu jadi 7. Kenapa kena jadi 7? Sebab kita balance left and right, dia mesti 7 tolak 1, dapat 6. You must 7 minus 1, you get 6. And then, the mass number is still, because electron is 0, because it has no, electron, it has, excuse me, electron, yes, no proton. Electron is just electron. It has no proton or neutron. No proton or neutron. So that's why the mass number is 0. Okay. So is 14 still remain constant. 14 still 14. So it's like 14 equal to 14 plus 0. The left and right must be the same. You must compare the mass number. Left and right must be equal. 14 equal to 14 minus 14 equal to 14 plus 0. Must be equal left and right. The proton number also must be equal. Proton number 6 equal to 7 minus 1. So left and right still 6 proton. Understand? So it must equal left and right. Now look at here. So you can see this 6 already become 7. Remember that? What this 6? What we call this 6? Remember we learned about this? X equal a z. Remember this? What is it called? What is it called? This one? We call this. Have I changed the phone? Okay. This one is called the proton number, or you call it atomic number. Atomic number. The Z is called the 6 and 7. They are called atomic number. Why is it called atomic number? Because atomic number means the identity of this element. Identity means it become a different. Kalau nombor ini berubah, macam ini 6 jadi 7, identity of atom itu sudah jadi atom lain. Dia tidak remain carbon sudah. Dia tak boleh remain carbon sudah. Kalau 6 jadi 7, means elemen ni bukan sudah carbon, dia mesti jadi benda lain. Kalau 6 jadi 7 yang elemen yang ada 7 proton is nitrogen. It become a different atom already. Understand? So it changed to another element. Yeah, carbon become nitrogen. So it changed to another atom already. Yeah, because the atomic number change. Atomic number change means it changed to another atom. So it become nitrogen. Yeah, nitrogen has 7 proton. Yes, yeah, nitrogen has 7 proton. Now, mass number still the same. Okay, now I want you to count the number of proton and number of neutron for carbon and also nitrogen. So carbon, it has 6 proton and it has 8 neutron. And when this 6 becomes 7, because it's 6 equal to 7 minus 1. Okay, so look at this nitrogen. How many proton? Nitrogen? 7 proton. How many neutron? Class, how many neutron? 14 minus 7, you get 7 neutron. Do you see that? Neutron becomes 7 neutron. So you compare. I want you to compare the proton, the number of proton and number of neutron. What happened is the proton has increased by 1, but the neutron has decreased by 1. Do you see that? Do you see the proton has increased by 1, but the neutron has decreased by 1? So what does it mean here? That means it is the neutron, one of the neutron has changed to proton. One of the neutron has converted to proton. Understand, class? The neutron kurang 1, tapi proton tambah 1. Apa maksud? Maksudnya, one of the neutron changed to proton. Understand, class? Give a thumbs up if you understand. Okay, good. Now, so why this happen? Because as I said, this carbon 14, it has too many neutron compared to proton. 8 neutron compared to 6 proton. So too many neutron. So to balance out, one of the neutron here have to change to proton. So that's why minus 1 plus 1 become balance. 7 proton, 7 neutron. Then this one is stable. Last time this one unstable. Carbon 14 is unstable. Now the nitrogen become stable already. Understand? This one unstable because it has too many neutron. Now it have to beta negative decay. So now it become a nitrogen 14 with equal proton and neutron, and it is stable already. Understand? Now look at here. When emit electron, it must emit anti-neutrino. It must emit in anti-neutrino. Electron with anti-neutrino. How to write Antineutrino? V, bar V. Bar V. Antineutrino. Kalau elektron mesti pair dengan antineutrino. This antineutrino is just a, what is antineutrino? It's just fragments lah. Just a fragments of this decay. Just a fragment. It is uncharged. I can say uncharged. Yeah. This is neutral. Yeah, neutral, uncharged, neutral particle. Just a fragment. Yeah, sepehan saja. And then if beta positive decay, we have neutrino. Tadi apa? Tadi antineutrino. Ini neutrino. Apa beza dia? Antineutrino is antiparticle of neutrino. Just like we learn what? We learn about positron is antiparticle. Okay, we have this element here. We have electron. We have neutrino. This antiparticle. This particle physics lah. If you're interested, yeah, neutrino. We have antiparticle, a reverse version of them. Yeah, we have positron, yang positive charge punya, yeah, electron with positive charge. And then we have neutrino. We also have antineutrino. Okay, write it. Antineutrino. This antineutrino is the antiparticle of neutrino. Just like positron, antiparticle of electron. Yeah, like that. But we must know the pairing. Yeah, kalau emit electron, dia mesti dengan antineutrino. Kalau positron, positron dia pair dengan neutrino. Remember, look at here, you see. You see that? Kalau dia keluarkan positron, dia mesti keluarkan neutrino sekali. Neutrino macam mana nak tulis? Neutrino ialah inilah. Dia tak ada bar. Dia just V saja. Kalau positron dengan neutrino. Kalau elektron dengan antineutrino. So neutrino ini dia juga neutral juga. Dia tak ada charge. Dia sepehan saja. Tapi apa beza? You kata apa beza antara antineutrino dengan neutrino? I just say that antineutrino is an antiparticle of neutrino. Nak kaji lebih banyak sifat mereka, so bukan dalam silibus kita lah. Itu you nanti kalau future you tengok itu particle physics, nanti you kan belajar lah apa beza dia semua ya. Okay, just learn today is is a antiparticle. Is just an antiparticle of this ya. Okay, now tadi kita sudah belajar beta negative decay, too many neutrons. Sekarang beta positive pula. Beta positive is a positron decay. It's also this what carbon. This one also unstable. Yeah. So let me draw. Yeah. This one. Yang ini pun unstable juga. Kenapa dia unstable? Sebab dia too many protons. Dulu too many neutrons. Kali ini ialah too many protons compared to neutrons. Dia terbalik. Dulu ialah neutron convert to proton. Sekarang ialah proton convert to neutron. Dia proses terbalik lah. So mari lihat contoh. Dia terlalu banyak proton berbanding dengan neutron. So terpaksa untuk balance out, dia proton kena convert to neutron. So tengok contoh ni. We have carbon. This is also carbon. Yeah, carbon 610. Tadi ialah carbon 14 kan? You see? We have carbon 14 and then here we have carbon 10. Apa beza dia? It's still the same. Same element. Carbon 6, you see? 6 proton because we call it isotope. We carbon 10 carbon 10, 6, and carbon 14, they are called isotope. They are still the same element. Just different mass number. Different mass number. They are isotope. Isotope means they are same element. Why same element? Because they are same proton number. Understand? 6, 6. So the proton number is the atomic number that determine what element. Okay, now look at here. So this carbon 10, when emit the positron is positive charge lah. Ya, dia positive 1 di sini, positive 1. Dulu negative 1, sekarang dia positive 1. Ya, mass number is 0. Ya, because no proton, no neutron. So tapi dia punya dia punya charge dia positive 1. Positive 1 di sini. Ya, positive charge. Ada positive 1. So bila balance left and right equation. So here 10 equal to 10 plus 0. Mass number constant lah. Okay. Then proton number is 6 equal to 5 plus 1. Dia mesti 5 lah. Dia tak bolehnya maintain 6. Dia tak boleh kekalkan 6. Because sini ada plus 1. Plus 1. So dia mesti 5 plus 1. Tadi ialah 7 minus 1. Ini jadi 5 plus 1. 5 plus 1 is still 6. Tadi 7 minus 1 is still 6. Understand? Now is 5 plus 1. So ini kena 6 jadi kena kurang 1. Kena kurang 1 jadi 5. So 5 tambah 1 menjadi 6. Understand? Okay. Now look carefully what happened at the proton and neutron level. So this one has 6 proton. Yeah, 6 proton. And then 10 minus 6, you get 4 neutron. See that? Too many proton. We have 6 proton but only 4 neutron. We have 6 proton but only 4 neutron. That means too many protons. Now, when you have beta positive decay, that means sini sudah tambah 1. So sini sudah jadi apa? 5. 5 tambah 1 ialah 6 lah. So, okay, tengok. Sini berapa proton? 5 proton. And then 10 minus 5, we get 5 neutron. So, ini equal lah. 5 proton, 5 neutron. Equal, so they are stable. This is stable. So, what happened here, class? Look carefully. What happened here? What happened here? What happened to the proton and neutron here? Ini proton sudah tolak 1. And what happened to the neutron? What happened to the neutron? Tambah 1. Betul tak? Neutron tambah 1. So what happened here actually, class? Kenapa proton tolak 1, neutron tambah 1? Kenapa? Because one of the proton, satu proton sudah tukar jadi neutron. Faham tak? Bila dia keluarkan positron ini, salah satu proton sudah convert jadi neutron. That's why protonnya kurang 1, neutron tambah 1. Okay? Understand? One of the proton change to neutron. Yeah? So that's why proton decrease by 1 and then neutron increase by 1. Understand, class? Now give me a thumbs up if you understand. Okay? So that means this one last time too many proton. Now it has one of the proton has convert to neutron, so that now it become balanced. Yeah, proton and neutron become balanced. So from unstable become stable already. Become stable after beta positive decay. We call it beta positive decay. Okay, and remember when emit positron, it always come with neutrino. Kalau electron always come with tadi positron come with neutrino. Kalau electron come with anti-neutrino. Okay, now selesai. Now look at gamma decay. Gamma decay. Gamma decay is called ray. It's not called particle. Yeah. Last time Alpha is a helium particle. You see, particle. Alpha is a particle. Beta, yeah, beta also particle. Alpha is particle because helium. Beta is a particle because electron or positron. Now, gamma is a ray. Is a ataupun kita panggil wave lah, gelombang. Because it's actually or we call it light wave lah. Dia cahaya. Ya. Lebih tepat ialah EM wave. Lebih tepat ialah EM wave. Yeah, it's actually photon. Photon. What is photon? We can say photon is like light particle. So lah, light particle. Yeah, macam particle, but it's not a real particle. It's in terms of energy. In terms of energy, this light particle carry energy in the form of particle. Tapi dia bukan secara physically dia particle. Just in terms of energy, it carry in bundles, in particle form. Ya, photon, light particle. Ya, tapi dia gelombang sebenarnya. Ya. So gamma decay. Gamma decay is kita tulis dia begini. So kan kita sudah belajar alpha. Kita boleh tulis dia begini, alpha ataupun helium 2 4. And then we have beta. Boleh tulis beta positif ke beta negatif, ya, ataupun dia adalah kita kata ini elektron positif 1 ataupun elektron negatif 1. Okay, and then we have gamma. I'm grandma pula, ya. Gamma menjadi grandma. Okay, gamma dia begini. Satu ikan, ya, satu bentuk ikan. Okay, come on, gamma. Kurang satu mata, ya. Okay. Okay. So gamma ray, ya, gamma ray. Inilah cara melukis, ya. It's a photon, ya. Okay, since dia adalah satu gelombang or ray, so it doesn't change the element. You see that? It's still carbon. You see? Gamma decay, dia carbon menjadi carbon. Dia tak ubah. Dia punya proton number. It didn't change the proton number. It doesn't change the element. It's still carbon. Why? Because dia tak keluarkan particle. Dia just come out energy. We can say this photon. This is the photon. It's just energy. Energy is emitted. Through photon. Photon is actually like the energy bundles. Energy bundles. So that's why it still maintain same element. Kalau dulu beta decay mesti tukar elemen. Carbon menjadi nitrogen, carbon jadi boron. Dia mesti tukar elemen sebab dia tukar dia punya number of proton. Dia punya number of proton tukar. So it become different atomic number. Kalau helium lagilah, helium 2 4 kan. 6 become 4. So it also become different element. Dia punya proton number berubah. Ini pun proton, beta pun proton number berubah. Tapi kalau gamma, proton kekal sama. 6 6 12 12 kekal sama. So apa yang beza ialah ini excited state. This one is at ground state. Kamu ada belajar tentang excited state and ground state? Excited means high energy. Excited, high energy. Bila dia sudah keluarkan energy through photon, through the gamma decay, then become low energy. Ground state. So, but the element is still the same, maintain carbon. Just excited state become ground state. High energy become low energy. Why? Because energy sudah keluar dalam bentuk photon, dalam bentuk light particle. Understand? And high excited energy state become low energy state. So that's the difference, yeah? Gamma decay. It doesn't change the element. Now look at here. Alpha is positive 2, yeah, because it's helium-2, helium-24. So it has positive 2. Beta is negative 1 or positive 1. Gamma is uncharged. Yeah, gamma is not charged at all. Deflection? Yes. Deflection by electric and magnetic field? Yes. Alpha got deflection. Beta also got deflection. Why? Because positive charge. Kalau positive charge, remember? Kita ada belajar Fe equal to QE kan? Dia ada force. Kalau dalam electric field, dia ada electric force. Kalau dalam magnetic field, dia ada BQV sin theta. Remember we learn about this? BQV sin theta? Dalam electric field ada electric force. Dalam magnetic field and moving, kalau moving, the charge is moving, dia ada magnetic force. Dia ada magnetic force. So it will have deflection. Dia mesti ada deflection. BQV sin theta, QE, dia ada deflection. Alpha and beta. Gamma no, because gamma is uncharged. Gamma no charge. It's just a ray. It's just an electromagnetic wave. This gamma is uncharged. So dia macam ini lah. Dan tengok ini. Deflection in electric field. So dia ada apa? Ada magnetic, ada electric force. Kalau gamma straight saja. Ya? Kalau magnetic field dia ada BQV sin theta. Q kan charge itu positive charge. Alpha deflect ke sana. We use what? Right hand palm rule. Remember our right hand palm rule? Kalau negative charge, dia pergi sebelah pula, ya, to the downwards. Gamma straight, ya, no deflection. Ionization power. Okay, ionization power. This alpha is strong, but gamma is weak. Why we say that? Because kenapa alpha strong? Because it's a big particle. Dia helium ini, helium is a big particle, so dia langgar dengan lebih kuat. Helium-24 is very dangerous. Helium-24 is big. It's a big particle, so they're strong. Yeah, the strong ionization power. But beta kurang sikit sebab dia elektron je. Dia elektron, so dia punya particle kecil, tak sebesar seperti alpha, ya, helium. So beta ni kecil sikit particle dia, elektron saja. So dia punya ionization power moderate. Tapi gamma weak because it's just a ray. Dia tembus sahaja tanpa mencederakan yang dia tembus, ya. Benda yang dia tembus itu dia tak cederakan. Okay, dia tak cederakan, dia tembus sebab dia just a ray. So benda yang dia tembus itu tak cedera. So ionization power dia weak. Understand? Alpha is the highest ionization power because it's a big particle. Now penetration power, of course, the gamma is the strongest. Gamma is the strongest because it's the smallest particle. It's the smallest. Dia bukan particle pun. Dia is just a ray. Just a ray. So dia paling senang tembus. Tengok ini. Gamma, dia tembus paper, tembus aluminium. Only can be filtered out by a plumbum. This lead is actually the plumbum. Plumbum. Berapa lapisan, berapa apa? Tak lupa sudah berapa cm, berapa ya. So penetration power gamma is the strongest because dia is just a ray, sangat kecil, boleh tembus. But alpha is the weakest because it's big. Sebab dia besar kan? Dia besar, so dia paling senang ditapis. Alpha ni paling senang ditapis oleh satu kertas sahaja. Sekeping kertas dia boleh tapis alpha particle. Tapi paling cedera ialah paper lah. This paper paling cedera sebab dia kena ionize. Paling cedera lah, ya. But penetration power dia, alpha dia kecil sebab dia alpha particle besar kan. Begitulah kelas. Okay, so sebab dia besar, so sangat susah nak penetrate. Ya, alpha dia besar, so sangat susah nak penetrate. Ya. Beta can be filtered only by how many 10 cm aluminium begitu ya. Aluminium. Okay, ability to affect a photographic plate. Photographic plate, yes, all yes ya. Boleh we can use photographic plate and also fluorescence to detect all ray. Yeah, we can detect all ray, alpha, beta, gamma to detect. We can detect the presence of alpha, beta, gamma using photographic plate or fluorescence. Okay, akan ada cahaya. Okay, so I think that's all for today lah ya. So this decay law and this all these equations I will teach in the tutorial later on. Just 3 more slides, yeah, and we can finish our whole syllabus. Alright. So these are some theory for today's lecture lah. Yeah, some theory. Then after that we can learn about all the equation to solve some problem. Okay, understand class? Understand today's lesson? Okay, so that's all for today. Thank you, class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Okay.